the second video in section 8.6, trapezoids. We just wrote down the vocabulary words and some properties of isosceles trapezoid and then just a regular trapezoid. I want us to take a look at example number 1 together. So here's a quadrilateral, has one set of parallel lines marked congruent. So this is a trapezoid. Now, is there any indication that tells us it's going to be an isosceles trapezoid? No. So we just have to go with just regular trapezoid. They didn't tell us anything that would lead us to believe it's isosceles. Okay. So our directions are to find the measures of all the angles. That means I need this angle down here and I need this angle up here. Okay. Now, is this angle just going to be 125? No, not necessarily. It would be the case in isosceles trapezoid, but remember, we don't know it's isosceles. Okay? So how are we going to find this angle that we are missing? I want you to remember something you know about parallel lines. If you got parallel lines, there are lots of different little things that you could think about way back in chapter 3. Okay? I'm going to extend out the parallel lines. How many transversals are there on this picture? If you remember what a transversal is, the transversal is any line that cuts through two other lines. Okay? And the cool thing is, there's lots of things that happen when we have a transversal cutting parallel lines. So, take a look. This angle 125 and this angle down here that we need, these are a special pair of angles because of our parallel lines here. Okay, do you remember what those angles are called if they are on the same side of the transversal and they are inside your parallel lines? These two angles together, they are called consecutive interior angles. We talked about them with parallelograms, because parallelograms have lots of consecutive interior angles. Trapezoids also have consecutive interior angles. Here's a pair. Okay, we'll talk about the other pair. There's another pair over here. But let's go ahead and solve this for this angle down here. So what do we know about consecutive interior angles? The sum is always going to be 180. In other words, they are supplementary. Okay, so if I know I have a total of 180 degrees between these two, I'm just going to skip over here, and my total is 180. That's what supplementary means. If I already have a 125, let's just subtract that from our total 180, and that's going to tell us what we're going to be left with for this other angle to be. Okay? 180 minus 125 is 55 degrees. So our answer for one of our angles is 55. Okay. Up here, can we use the same logic to solve for this one? But you got to look at your other transversal. Do you see this other side is acting as a transversal? So how are we going to find what this other angle should be? I'll circle this pair with my brown marker. Consecutive interior angles, again, your total's got to be 180. This is a little bit easier one. The numbers, that is. Because if you have a total of 180, you already have a 30 there. What's left over for that other angle that you're missing? 150 degrees. Your final answer for this angle down here, I didn't label these, but just to be really clear, we could put A, B, C, D on your trapezoid there, and your answer for angle A, down at the bottom, we found to be 55 degrees. Your answer for angle C, up at the top, we found to be 150 degrees. And this answers my question. Okay. Now, example 2 here. Find all angle measures in this isosceles trapezoid. Very important to read your directions very carefully because this gives us a clue that's going to be really helpful here. Isosceles trapezoid means what? That both of the legs are congruent to each other. Also, what other properties do we know? Isosceles trapezoids have two sets of base angles. Okay, if you will remember from your index cards, you can have them right in front of you. Take a look at the picture there. Where are your two sets of base angles? I want to point this out. These down at the bottom, do you notice that both of those are acute angles? And take a look at the top. These are obtuse angles. That's also going to happen in every isosceles trapezoid. You're going to have one set of acute base angles. You're going to have one set of obtuse base angles. All right, what is true about your base angles here? They are congruent to each other. So if this one's 120, this one over here has got to be 120. Let me give these names again. So the measure of angle B, we just found to be 120 because it is congruent to its other base angle. Okay, we do know that D and C are also going to be congruent, but what measure are they going to be? How are you going to find that out? Think about the logic we used over here. We still got parallel lines here, so look at your transversals. We can still use this consecutive interior angle fact. Okay, so here are your parallel lines. Here's a transversal cutting through. If I've got 120 as my obtuse angle, then what does this one have to be to give me that total of 180 there? Well, do some quick math. 180 minus 120, and that's going to leave you with 60 degrees down here for angle D. If that is true, since this is an isosceles trapezoid, what can we just automatically say that angle C also has to be? That's your other acute base angle. So angle C is going to be 60 degrees. Okay. These are two examples, one of a regular trapezoid, one of an isosceles trapezoid. You may see lots of problems like this. The concepts that you wrote down are now applied, and you can use those properties to solve any problem.